Hey everyone, thanks for joining us on another LinkedIn Live for OpenTower Designer. And this one will be covering guide towers in OpenTower Designer. And we have here Pankaj, our User Success Manager for OpenTower, who's going to be walking us through and taking any questions you guys might have. So anything comes to mind regarding guide towers, definitely feel free to shoot them in the comments and we'll get you some answers. I apologize, last time I think we got some questions, but they didn't show up until afterwards. So regardless, I'll definitely type you a response if I don't see them come in live. But I'm monitoring them consistently to get you guys an answer. So Pankaj, thanks for putting together this model and joining me today. I know we kind of want to focus on the specific things to guide towers, so let's go ahead and do that. So obviously, kind of one of the unique things about guide towers that separates it from monopoles and self-supporting is going to be the torque arms. So I wanted to see if we could start with that. Like, what kind of options do we have in OpenTower Designer for torque
Sure,
arms?
we'll
And
sure we'll do that. Well, I'm happy to be here, and this is Open Tower Designer, and as you can see that, first let me start with this thing. Guide towers are easy to climb; they are the fun part. But
because
when
they're
you
so
get to the
narrow, right?
Torca,
Yeah.
yeah, and easy to manage. But the fun part is when you get to the Torca, you really hit the point.
When you say fun, are you being sarcastic?
Kind of. Think about this way. If I am, can I squeeze big guy like me? Can I squeeze it from here?
Oh,
No.
gotcha.
And to measure all these member sizes and everything, it's never easy. But hey, thanks to all the climbers, those who do this job, it's really
Definitely.
difficult. And especially guide towers, they are very tall towers.
Hmm.
And I have heard that towers are like 1,500 foot. I knew a couple of colleagues in the TI committee and everything, friends, circles, and even like Nate from the Nate Society, some climbers, they have done those kind of jobs. Even a couple of our senior leaders in the TI committee, they climb towers too. So I
Yeah,
have
I'd have to
heard
take a
about
break
a
every
lot.
10 feet. 5 minute break
Well,
every
I'm
10
not
feet for
sure
me.
10 feet, but yeah, I'm sure to think about this way. Self-supporting tower, 250 foot, 300 foot, you can do it in a day. But 1,500 foot guide tower, it's
Jeez.
amazing the view from the top of the tower. Okay, so let's keep those things side apart. So here is the tower count, right? So the TARCOMs are very, very important. And let me say that not all the towers, guide towers, might need TARCOMs, but there are some towers definitely need TARCOMs.
Hmm.
And the TARCOMs are the purpose. Some people call it as TARCOMs, some people call it as a cross arm, some people call it as a stabilizers, because at the end of the day, they are stabilizing the structure, and they are trying to restrict the torsion on the structure itself.
Hmm.
So but this is a, this is looks like a very simple torque arm, right?
Hmm.
Well, in real life, not all torque arms are very simple. They are some crazy torque arms, and we believe that the members, different members, which are, let's say this is a pretty big member, right? Can you see my cursor? I'm pointing
Yeah.
to. This
Yeah.
is called as the one of the. This is one of the wing style torque arms, and there are for a lot of different types of cross arms. We give the name called wing style, dog ear, bat
Hmm.
ear, channel, all those different types of names. But these are sometimes they are already braced in the middle also, so the bracing is not only like the behavior is like, hey, just brace it, and whether what we can do is it's just reducing the k factor.
Hmm.
But in reality, reducing the k factor is just limited to the design part, right?
Right.
But our intention is, hey, why not let's take the stiffness of that member too in the structure. So we created the tool where users shall be able to add all these other members. Let me do one thing very quickly. I'm gonna
So we're
just.
capturing the added stiffness from any truss elements added to the torque
Oh
arm,
yes,
as well
yes,
as
yes,
any
yes.
wind loading
Uh,
that gets
Any
caught
wind
by
loading.
those.
Uh, oh yeah. So for wind loading also, you hit another good point. So wind loading on cross arms, right? It's not, well, as if we go to the TI code, right? We have the definition of a panel. We know how to calculate the wind area on a panel based on all those dimensions. But how the cross arms? Cross arms are out of the boundary of the tower, right? So they are external members, but
Hmm.
they are the one contributors of transferring the force from the guys to the tower structure. from these members, right? So they are acting as a tension and compression members. So it means for us to calculate the proper wind load on them should be a proper approach for it, right? So OpenTower Designer follows the approach of as a guy member, like the way we calculate the wind load on a guy because it's at an angle and it's a single member. So that's how the approach we applied on a on cross arms as well or torque
Hmm.
arms. Okay, so that's very important because stiffness is important as well as the wind load. Because if you consider that whole area and apply it the center, that's a different concept than you apply the wind load on each member and how the
Each
let the
discrete
forces
member. Got it.
each discrete member and let the forces travel to the structure the way they should be. You know, so
It's a
that's
truer analysis rather than a simplification.
yeah, assumptions are easy to make, but what we don't know, like how the assumptions are transferring the forces to the structure, whether they are means how much risk we are taking in that level. And the good thing I can tell you about guy towers, in self-supporting tower monopole, if you add antenna or remove an antenna, you can easily predict the stress analysis. Hey, I'm removing a five square foot area of the antenna. Now I'm putting with a 2 feet square, so my tower will be a little bit less stress than it used to be, right?
Hmm.
But guide towers, it's hard to unpredict because sometimes removing the antenna from the guide tower can fail the guide tower
Oh wow.
because it's all about like how the initial tension is playing the role of the cables to the tower, and how the tower is getting balanced from all these loadings, and it plays a pretty big role. So guide towers are really, yeah, difficult
So
to understand the behavior of it.
so it's probably
So
safe
let's
to
talk
say
about
you don't want to be conservative or even under conservative because
when
you
you're
want
doing the
you want
predictive
the truest
analysis. Yeah.
analysis. Yeah.
Yes, yes. For guide towers, I would say that let's say if it's 70%, doesn't mean that it's going to fail by 100%. Removing the dish from the tower might be like creating a different impact on the structure that it might go to 78%, let's say, or 80%. But
Hmm.
again, those are not, I'm just throwing the numbers. The
Sure.
predictive
Sure.
analysis is always like all about like, hey, it could be this much, but we cannot do the predictive analysis on guide towers. That's the theory. But
Hmm.
here I wanted to show you like, so this is our guide detail tool where we have prepared the, allow the user to define their torque counts. There
Got
are
it.
we support wing style, bat ear, dog ear, channel, pull offs. These are 5 of them, and in our upcoming release, uh, we will have like a lot of other different user can give their names as well. They don't have to stick with only these ones. So we are
Perfect.
opening the doors for allowing the users to create these types of torque arms. Okay,
Got
so
it.
now think about this way: we have like wing style. Wing style has a top diagonal. Wing style has a bottom diagonal, right?
Uh-huh.
And then I have a top strap member where this like the upper diagonal meet to the tower structure, and then we have
Hmm.
bottom strap. But I have seen that there are some of the members are which are connected to these two diagonals just to reduce their unbraced length in that plane, right? And sometimes you have a plane bracing also. So we put all these different member list here. You can think
Wow.
about it,
Yeah.
and we have had it. Like let's say we will put some members. Let's say we will put a redundant diagonal, um, and let's put a angle section there. And again, we have a pretty big database here so that user can use it. Like, if they're looking for anything which is not in which was in the older version of the AISC catalogs, we have that. If they want to create their own section, we have that. So we
Perfect.
have SPC. SPC is called Structure Property Catalog.
Hmm.
We have a standard AIC sections, and we have a custom catalog where user can define their custom sections. So here it is like let's say we do this one, we'll add this one, and then let's add maybe a couple of top section horizontal. Okay, I just want to show you like that the capability of the, it's not like about the capability of the product, it's about what is true in the field. Do you have
Right.
the tools to take the advantage of it? I know like adding a lot of members sometimes takes time, but hey, at the end of the day, you are getting the true picture of your tower, which is the key because guide towers are very, very critical, you know, and that's why.
Yeah.
So
If
let
we're doing
me
a
say,
reanalysis of an existing tower, you really want your pencil sharpened so we're not
oh yeah,
doing unnecessary modifications.
oh yes, yeah, because sometimes just putting a K factor of zero point 0.5 to the diagonal might help your design member, like. But do you see this?
Perfect.
So I now my analysis will happen in such a way that for the wind load also I will be applying the wind load on these members too. And the wind load, the way it gets applied, it will be applied for each wind direction separately. So and we report these wind loads for the cross sums. I'll show you very quickly on that part. So let's say
Okay.
if I'll say set active, right? So now I have this one. So I can create any type of members there. We have in our catalog. We did talk about that. If if we go to our, we have images for like different plan basings. Sorry, I'm scrolling a little fast here.
It's all
Um,
good.
uh, so here you can see that. So there is a torque compressing. So we talk about it. Different members you can have it. They know what we call it under
You have all
diagram.
the
What we
naming
call it
conventions laid
naming
out
thing
there. Yeah.
convention. Yes, yes. So that user can look at it, what it is, and if they want to model something, they can. All those flexibilities there for that one. So
Perfect.
now let me show you this one. So here, so think about this way. Now the behavior of these members might change a little bit because the forces travel from this node to all the way to the tower could be different, right?
Right.
So it's all about, like, let's say if you have a, sometimes these tarcons or even the cables are, then you don't get the proper location of the anchor, so you move the anchor a little bit, so you have azimuths there, right? They are not 0, 120, 240. Sometimes it's a, hey, it's Earth. We cannot find the location. We just move around, right? So then you can easily manage, and those asymmetric loading can impact the different forces on the members. So that's why we say that the true picture for the modeling is important, because uh, what you entered in, based on that, your analysis is happening. That's what the true factor, instead
Got
of
it.
putting some factors there to get it done. So
Okay.
let me do quickly. While you are thinking more about the questions, I'm just going to show you that the generation load, what is
Sure.
happening there in terms of this particular file, and how
Sure.
those members gets area, like their load gets calculated.
But by the way, everyone else watching, feel free to submit any questions you have that come up as we progress through this. We definitely want to take it in any direction that you guys have questions on. So otherwise, we're kind of just gonna shoot in the dark and talk about kind of the unique features of guide towers and OpenTower Designer, which I'm sure will still be informative to everyone.
Okay, so here you can see that. So this is I'm saying that this is our training module. I use always all the time for the cables, for the training sessions. So this is where we can see that the cross arm load. You see that?
I see.
So, and think about this way: we are not telling the user, "Hey, okay, this is the area we got." It's difficult for anybody to understand. Hey, how did you get this area?
Hmm.
From where this came, right? So think about this way: we calculate the information about each and every member, okay, and then we say that, okay, then it applies the load. It will tell you what is the angle it's making with the wind for that member, so that they know that how these loads are coming from.
Got it.
And similarly, we have, for the guy cables, guy loads details.cs.
Got it.
It's everything, like, there for the user to understand what is happening. Hey, what gust factor they use, what is the drag coefficient they have used, all that stuff is applied. Again,
Yeah,
the
I like how we
angle of the,
still make all of this available to the user, but don't overwhelm them within the UI itself, because this is just a lot of numerical output. But in the event that you need to reference it, it's easily accessible for you.
yeah. So I think I really, you really definitely hit the bullet there, that if putting all this information in the report will be like making the report like a 1,000-page report. Why we
Right.
need to do that? So that's why these CSVs has been generated, so that user, let's say, due to some reason they want to reinforce the tower, but they want to see that, hey, how my loading is coming, where my pressure is going, what pressure I'm getting. Instead,
Hmm.
let's say if they want to do hand calculations, something, they have all that information available.
Exactly.
They don't have to do the maths again. They can save the time in like those complex maths, which it can be done easily by the softwares like OpenTower Designer.
Definitely.
So
So
go ahead.
I was going to ask you if unless you had another point on torque arms.
No, go ahead. Go for
I
it.
was just going to ask. I know it's a broad question, but if you could kind of at a high level explain how we analyze guide towers or what the general analysis process is for guide towers.
Yeah, sure. So Guy analysis, right? Think about this way. Guy tower is a non-linear cable analysis.
Hmm.
Everybody, we know all the book structure engineering books we read that hey, cable elements are non-linear elements and everything. So what unique about this Guy tower analysis? And especially when we say that what Open Tower Designer, let's say that what Open Tower Designer does it for us, right? So the way we do it, like in the field, how the tower gets erected. Let's think this way. So we put all these different panel assembly. Then we we connect these cables with the anchors, right? But while uh, putting these cables, so we put some tension on it, right?
Hmm.
So that the tower can stand. So, but when we put some tension, what is happening? So it's
You're going to
like
be compressing the tower,
yes.
right?
So it's shortening the tower, right?
Hmm.
So the what we do is when we do the analysis based on the initial tension given by the user, which I can tell you very quickly where we defined it before we go further. So here you can see that
Oh, I see. Okay.
initial tension, right? And you can also change the end fitting. We call it as end fitting efficiency. Means
Hmm.
like let's say you have a how you have connected the cable at the ends, like did you put the U bolts? How many U bolts are there? So based on like it's all about the there are some we have a ASC I believe a manual 72 or
So
something
the
where
EFE just scales down the
it
initial
scales
tension
down the
factor if it's yeah.
no the breaking strength of
Oh, is that
so
okay?
so the breaking strength of the cable, we reduce it. That we say that hey, because the connection is not producing the 100% efficiency, so
Hmm.
let's reduce it to the
I see.
90%. I have
Okay.
seen it. It all depends like how the let's say if it's like it's a couple of U bolts from the connection at the ends got loose. People have the flexibility to change it. But again,
Makes
so
sense.
with this initial tension, what happens is that when you put this initial tension before loading generation happens, like you have antennas and everything, but initial when they install the tower, this initial tension already caused some kind of a shortening effect on the
Hmm.
tower, right? So when we do the analysis, right? What we do is first we take the impact of the initial tension on the tower and deform the tower, and then we start going applying the wind load on the tower as well as the wind load on dish like any antennas on it or freelance and anything like that. So we
Got it.
applied that. So we call it as a two-stage analysis, but it all happens internally,
Hmm.
and you can see that. And especially with guide towers, sometimes they take time to run because the reason is that simple it is that you are pushing too much, you're putting the load on it. So here I will show you a little bit. We have this feature called uh, these are the different features we have added for guide tower analysis. There is a let's say most of the time what happens is some of these towers are fully like all those diagonal members, they are tension only members. So you can use the Euler buckling tension member, or there is another methodology called residual stiffness tension member. So we did all that effort there. Okay, now we talk about, so here you can see that we have checked box this one, retention guide to initial tension, right? If you uncheck this one, then it will become a one stage analysis. But if you check this
Mm.
one, then it becomes a two-stage analysis. It
Okay.
takes the deformed shape and then applied the load on the top of it. And we did describe this very well in our manual also. And it's in our, there's right here, you can see that where I'm talking about, um, where did it go? I just saw it like a minute ago. I think I'm scrolling the pages faster than I should be.
Yeah, I have no clue how you keep track of this, but I know this is like your Bible, so
Yeah, we need
you
to
usually find it
remember.
even after flying through it.
Yep, right here. You can see that. So here we say that what is happening to the TO and undeformed tower and deformed tower. Like that when under self-weight load case, how it's deforming and everything based on the initial tension impact itself. So this is like, we provided some information here, how the two-stage analysis works and what we do internally. And user can see all these things. The good part is that when we do, let me see if I have that file somewhere. Maybe I ran it the last, oh yeah. So here you can see that we have a analog.logx, right? Analysis.logx file. So if you open this one, it will tell you exactly what is happening. So it will tell you that whether the guy profile determination is like, think about this way, it's trying to uh, look for it that whether the initial tension applied got it converged to the tower or not, or it came to that level or not after the deformed shape. So once
Yeah.
you deform it, your cables got loosened, right? But you need to
Uh-huh.
maintain that initial tension. So that's what's happening here.
Yeah, I'm
So
glad you brought up the convergent side of things. I've generated a guide tower just using the default sections
mhm.
and the default yeah, guy wire properties, and had issues with it converging. So I know if you're going to design something from scratch, you might run into that scenario because maybe the stiffness isn't high enough in the mast itself. So at that point, would you recommend just you're basically it's an exercise of increasing the stiffness of the members on your mast in order to get it to converge, or do you have any input on that?
So yeah, so the way it works is like we have a couple of different methodologies already inbuilt. Let's say if it is not converging for you in any case, it means that either the cables you are using is not providing enough what do you call that enough stiffness is spring stiffness is there that they can transfer the forces properly. They are not
Hmm.
converging, they are like loosening enough that they cannot provide stability to the structure. So here
Right.
it's one of the good examples, like here you can see that we provide the table that, hey, uh, this is the initial tension we define, but after converging the tower, this is what the initial tension comes into the cable. So think about this way, it does all that effort for you to show you that what is the error percentage error also, because you said something and it's happening something else. So all
Yeah.
these things is open to the user, and then it keeps performing the, let's say if it's not converging, then what it does is it's throwing the forces slowly and slowly on the tower. Hey, let's try this one, let's try this one, let's try this one. Because the more force you throw on the tower, the more compression is going to be on the tower too, because you are increasing the you're pulling the cable more than it means you're pushing the tower down too.
Right. Right.
So all that stuff is happening internally, but we have this analog file which is it gets generated in the folder itself, and then you can check it thoroughly over there.
Perfect. I had another question. What does it look like? What's the process look like for modifying a guide tower within
Well,
OpenTower
modifying it,
Designer?
well, it's the same story what we did in our self-supporting tower, but
Okay.
I did put together something here for as well. So let's say I'm just assuming that this guide tower failed, or maybe somebody, you know, let's say this is a field mapping tower. So before that, I put all these three different levels of guide cables to the same anchor. But in reality, we are putting a new anchor, or let's say there was something mistake happened, right? So what I did is like, let me show you. Let me activate the scenario, and then I'll show you what I did in this case.
Okay.
So I have put together a modification where I created a new guide anchor.
I see.
So, and then it's automatically, and then I connected that new guy anchor to the bottom cable and just created it. So you can see that it will show you everything where it is, what is happening. The
The
blue
blue
color
indicates that
again,
that's the modification to the tower.
that's the
Yeah.
modification to the tower. And again, like you can always, if you want to know that how to do the modification on a guide tower, oh yes. So we have a, first you always deactivate the scenario. That's, we always say that because you are trying to change something in the geometry of the tower,
Right.
right? So it's just not like, it's a workflow, you should say that, that's
Hmm.
the way it should be. So I'm going to open this one, the one I created, and there you can change to the uh, guide tower. You have options to change to the guide details tab. You have options to change to any panel and provide some input to the connections, leg
So
connections,
where did
this
you
and
go
that.
to add the
I
additional
went to the
guy
guide
wires?
details. Okay,
Okay,
let's
that
say
makes sense.
we do that. I'll show another example here. So let's say I want to add another. This is also a very good tool we have it. Like, sometimes you have four different rows to columns to fill the data. Sometimes you lose track it, right? So let's say add a new row. So here is a new anchor guide tool
I
again.
see. Okay.
So you give your name. Let's say I will put Amir. Okay. So now let's say you have, let me open this one a little bit further. So there are some checkbox here, whether all anchors are identical or not, or all or there's a symmetrical arrangement or not. So symmetrical arrangement means that whether it's following a tower shape 0, 120, 240, or in case of 4 leg tower, it could be like, A45, 135, 225, or 320, 15, something like that.
Yeah.
So so now let's say if you put like 60, let's say we put 60, and think about this way, my automatically radius got filled, right?
Hmm.
So now let's say I don't want to do this all anchor identical. So I will say, okay, so let's say this one is -2, and this one is 2, and this one is -4. And then let's say my arrangement is not symmetrically there. It happens, you know. Let's say this is 10 degree, and let's say this is 120, and this is, let's put at 260 degree. Okay. So, and what we'll do is like, let's create a add row, and we'll put a new one. Let's say we will put this one as where we have. So let's put it at 100 feet. Okay. And we'll keep it as a pull off, and we will just put a strap there.
So I saw that you put a negative elevation on the in the
Yeah.
input. What
So
is that
oh
referring
yeah.
to?
So sometimes our Earth is not flat, right? Our ground. Let's say the ground is not flat. If there is there is a, like, maybe a small hill or maybe a small ditch where you want putting
Okay,
your anchor, so you can take advantage of that negative effect also.
I
So
see.
that you are increasing the length of the cable technically, because every tower starts from 0, 0, right, up.
Hmm.
But if it is if it's not the same location, then you can use that advantage of the elevation there. So that's where it is. So let's put this guy as, let's see, something. Maybe, okay, we'll use this one. And now here you can see that here we have defined the user a table here. So you can pick whichever, let's say if your cables are also different, you can do different cables, you know. So all that stuff you can do it very quickly. And here you can say that, hey, I want to use the middle anchor. Okay. And user doesn't have to get confused. Oh, I lost my data. What it is? It's right here. The diagram is right in the middle. What is 135 stands for? You can see that
Beautiful.
I can easily put the cables at 246 as well. All this data is available for the user. If you see that, there are options. So it's more like a flexibility here, um, for the user to how they want to define their tower. So let's say if we do this one and apply. Sorry about this one. Just this is one of my things which I have to figure it out every time when I do that.
No, that's perfect though. It showed us the process on how to make a modification where we're adding additional guys to the tower, which I think gets the point across.
Yeah.
Perfect.
So, but overall, like, this is the process where you will define the anchors and everything on it.
Perfect. I was wondering if we could also show what the process is like to add a guy anchor foundation and
Oh yeah,
perform those checks.
sure. So the way to we have guy anchor foundation,
Hmm.
and there are different options. So in this case, what I did is, like, let's say you want to create a new guy anchor foundation. So here I have 3 guy anchors, right? So you can see I have right now, I didn't activate the scenario, but let me do that very quickly and I'll show you that.
So we should see the additional anchor points since scenario
Yes,
2 has additional guy wires. Okay.
yes. So now you can see that I have the middle anchor too, right?
Yep.
I think I need to create new new tower models, sky tower models. So, well, let me show you a little bit on the top. So here you can see that.
Sure.
Do you see all these things? They are not in symmetrical and everything. So you can
Right.
see that it shows up there where it is and everything. So that's where it is. And now let's say if I go to the guy anchor, let's say I want to create a new guy anchor. So I can pick which one I'm defining.
Oh, okay. I see.
So you don't have to stick to only one foundation and do the analysis and design. You can define anything over there. So we support both guy anchor block as well as, let's say for middle one, we will do the guy anchor block. Okay. And let's say here it is. So let's say most of the time I have heard that, like, hey, the anchor block is, we don't know the reinforcement and everything, how we analyze it and blah blah. Hey, we have a tool called exclude rebar.
I see.
So it will check the overturning and sliding check for the guy anchor foundation.
Yeah. I assume they
But
could, as engineers, probably assume the minimum reinforcement is a safe bet in the event that you don't have any documentation, or
oh
what's
no,
your experience on that?
well, my experience is that sometimes we really check that whether, let's assume that there is no reinforcement,
Oh, okay.
because we are checking for, see, guy anchor block is a pull, right? It's all about pulling it. Like
Hmm.
it's not about like you're checking any movements on it. So so the better it is, like what it if you are checking only for the sliding check and over like a sliding check and the uplift of the anchors. So rebars are not playing that much role there, but they definitely help. But they are like you can check without that too.
Got it.
But yeah, if it's a mat foundation or a isolated footing, you're doing for where your forces are coming to them, and you have a punching shear happening, you have a one-way shear, two-way shear, and all that stuff is happening, movements and all that stuff. You need to have a. I will say that it's better to have a minimum reinforcement criteria from ACI should be used if you don't know anything about it, because at least mat should be designed for that, right?
Makes sense.
So here it is, like you can fill up all this data,
Okay.
and also, like, if you remember, I just select only A and B, right?
Uh-huh.
So it means I am thinking of it that, hey, what if I want to have a drill pier on my inner anchor C?
Oh, okay. So you can have
So
varying foundations if that
varying
occurs.
foundation also, and it's possible too, because guide towers are, so guy tower is a slender structure, right? But the
Hmm.
guy cables are going. If you go check it on highway, sometimes they are like going all the way like 100 foot, 200 feet far away from the guy tower, right?
Yeah.
So it means you don't know the soil profile over there. Could be like it's
True.
a very silty soil and everything. So you maybe drill pier is the best option,
Yeah.
not the guy block. So that's why we have the option for the user of flexibility, where they can have define the multiple foundations on the different guy anchors. So for drill pier also we have the similar concept. You define the soil parameters, you can define the drill pier, and in drill pier, I think foundation should have a separate topic. Maybe we can go in detail one day. But it's a pretty vast topic, like what we do and everything, and maybe we can invite our professionals in this one, like call like Purba Trivedi, who's our senior director for Tower Products. Maybe I can request him to come and talk about foundation, that what we do, and where the how the rebars has been aligned. You can do multiple rebar cages, like which is common, like drill piers, like sometimes the piers are like 8 foot diameter, 10 foot diameter, and the cage, rebar cage, could have multiple rebars also,
Hmm.
cage also. So all that stuff you can do it here. And sometimes the diameter changes from the top to bottom. You can model that one also, and it performs the calculations for you.
Perfect.
So
Yeah, that was a
anything
good
I
little
can.
overview of the foundation checks. And then we're checking all the basic limit states,
Oh yes,
soil
yes,
checks, concrete checks. Are we
yes,
getting
yes.
into the actual steel checks on the anchor itself, or where do we stand on that?
No, we do that, but again, like if it's exclude rebar, you don't see those parameters, calculated in the report. And but if you have the rebar, then those rebars results will be updated too. If
Oh,
I'll show you very.
I meant the actual anchor that gets cast into the concrete foundation. Is
Oh, the
is
anchor
that an
rods.
external check?
Yeah, that's an external check. Because
Got it.
think about this way: the way, see, drill piers for self-supporting tower is different than for the guide towers, right? Because when you are talking about the anchor, there's only one cable, which is one rod shaft. We call it as the anchor shaft, right? The
Hmm.
one I showed you here. Let's say if we go to guy anchor ID very quickly, and this is anchor shaft, right? So that's the one
Yeah,
where
that's
all
what I
the
was referring
cables
to.
are connecting. So
Hmm.
here we have this one. Look at this. We take into consideration the impact of the anchor shaft also. You define the diameter, you define the area override if you want to do that. We check the tension capacity of this one too.
Got it. Makes sense, and that's perfect. Okay, perfect.
And
And then, not to set you up to close out of your streaming service again, but I was wondering if the OpenTower profile page also works for guide towers, where it kind of gives you a
Yes,
summary
it does give you a summary. So how about this
of.
one? Let's do. I'll activate the scenario number one, and
It
we'll
might be a
go
little bit
very.
short, right? Since we're not going to solve it, it might not have all the output, but just to
You know
show
what we can
off.
do? So just to show off, so what we can do is we can have a very good way of doing it. Let's say we'll go to the win definition and we will say that, hey, I don't want to do it for all the load cases. Unselect all, and
Oh,
I'll just
good
say,
idea.
okay.
Yeah,
So we'll save our time.
perfect.
So let's set activity scenario. In the meantime, we can. If you have anything, I can talk about it. And if you have any questions, I know you were asking me
Yeah,
about
our
like
I was just say our viewers
analysis.
are being a little bit shy. We haven't gotten many questions typed into the box, but if you guys are feeling more comfortable, definitely type something in
Maybe
there,
we are
and
doing
we'll.
good job that we are answering all the
Yeah, or
questions.
we're just
Maybe
answering every question they might have.
you know. So, but let me touch base a very very different topic here. I'm sure, like this is a very very interesting topic, which I learned a lot while we were developing this uh, Open Tower Designer especially for the tension members.
Hmm.
You know, we definitely provide the theory here. So what is happening when you use the different types of methodology for the tension members? We have we have provided a very good information here, a simple diagram, like what will happen if you have if there is a residual stiffness. You assume that the member is called as tension, but it's still taking some kind of compression. It's still,
Mm.
you know so how it works. So saying that, hey, that member doesn't take compression. Yeah, that's because we are saying that based on KL over R ratio, we are modeling it as a tension member. We just want that member to behave or react only in tension, right?
Hmm.
But those members might see some compression force also, right? So that's why we have provided a two different methodology for checking the tension type of towers, tension member towers. So one is called residual stiffness tension member, and there is another one called Euler buckling tension member. So what we do is like in tension residual tension member, have the alpha factor, which is between 0 and 1, and they are, we calculate internally. We increase the stiffness little bit to make it, converge, because you're talking about the guide tower, which is like, sometimes they have 6,000 members.
Wow.
And so, yeah, so three faces of the tower, and panels for the guide towers are different, because a 20-foot panel might have a 6 bays, 7 bays, or maybe I have seen 8 or 9 bays also. So so there are a lot of members there, right? So convergence cannot be feasible, because now the legs will be start buckling, uh, eh, and deformation is so much that they cannot support it. So that's why, we there is a methodology in the structural analysis portions, where there is a methodology called residual stiffness tension member, where we, based on what users select, we follow that approach internally. If it says like in residual stiffness tension member, that's where we have seen that it gives a much promising results than our Euler buckling, where you are saying that, hey, I know the member is tension, but there is a constant compression force is always there. That's a theory, and I think it's a well settled theory that, yeah, there could be, because that member is taking some force there, though we are asking it to behave differently. So let's come back to this part, and what I will do is I'll say generate load very quickly. Oh, I used only one, and we do the pattern loading and everything all on guide towers by default. If it is following the criteria, means if it meets the requirement, so you will see that all those different pattern load cases will automatically pick up. So let's say we'll say perform analysis very quickly. I hope it will do. So here, at this time, I can show you that I can open my analog X file, and it will keep showing me all the things it's doing it internally. So it says analysis successfully. So we have completed our analysis today,
Perfect.
faster than ever. So now here at this time, I'll say, hey, define foundation design.
Oh yeah,
So
we
if
could take
I,
a look at what that output looks like.
yep, so we can. So here that, think about this way. I had, this is for the base. I had
Hmm.
the isolate reporting.
Okay,
Then for anchor guy foundation, I had
perfect.
this one. So think about this way. Uplift movement, lateral movement will not show up if you have said that there will be exclude the rebar.
Makes sense.
Okay, makes sense, right?
Yeah,
Because we are not checking the reinforcement at that level. But if we are drilled peer foundation here, you can see that we have. I've defined for these three guy anchors. I had like two guy anchors as an anchor block, and the one is a drill peer. So that's where it is, and it will tell you everything information about it, what it is.
perfect. I like how it's all in
And
one quick interface. You can just
oh yeah,
quickly check it pass or fail, and then just make any changes you might need to make.
there is a good advantage of our tool, and you know that, let's say foundation, we have kept it separately because foundation has a different perspective from the user. Some user wants to do the foundation design, some they don't want to do that. Sometimes we don't have the information, right? The ask is only the tower analysis, so why will put an effort, right? So foundation design, let's say if I make any changes to the foundation UI now, you know I don't have to go do the analysis and design again of the tower.
Oh, perfect.
So yeah, so if I'll go there and I'll say like, hey, oh no, this one is the rebar is not 10, that's the 12. Okay,
Hmm.
12 count. So apply. Okay, it says that message, but I can say foundation design again. It will do that based on
Because
the
it's still got the forces at that support,
at the
so that it can just
support. Yeah,
quickly recheck.
yeah. So we kept the foundation as separately so that the user doesn't have to reanalyze and design it based on their information. Let's say if they're creating a new foundation, sometimes we start with the minimum, but we want to expand it. Every time when you do the analysis, especially on a guide tower, it takes time. So why we need to spend that much time? So we give the flexibility to the user. Hey, if you are doing the foundation, why not you can have it. That was the again, it was the collaboration with our tower owner partners. They thought also that way that this is the best approach because it's easy for them to manage their foundation or draw the new foundation or reinforce the foundation instead of reanalyzing the structure again and again.
Perfect. Yeah,
Because
and
the
for everyone
loading the
watching
loading
who,
is not changing it. If the foundation is not loading is not changing, then what's the point of
right.
keep analyzing the structure?
Yeah, I just wanted to clarify too for everyone watching it's not a separate module that you have to pay extra for. It's already included with OpenTower Designer. So you already have access to it with your purchase of OpenTower Designer.
And I know you asked me about the. Okay, I'm gonna do that. Okay,
Yeah, be very
so just
careful not to close out of your
no,
stream like you usually do.
yes. So actually, this time what I will do is I'll be very careful and I'll bring this tower profile page separately. So here, let me show you. This is where you can see that we put a lot of effort because I didn't do the design part and everything.
Right.
So it provides all the information of your tower. So look at this. I have not done the structural design, but it says that the foundation rating is 78.83%.
Nice.
So here you have it again. You can just whichever the image you like it, you can take it and you can just use it for your
Yep.
report. And
I like
report
the
also, it automatically creates the report template. Also, there's a workflow for it how to create the report on that.
maybe move the window down so you don't click out of the stream
Oh
or
no, no, this
minimize
one
the
is
window or
different. No,
something.
this is a
Okay.
different one. I kept it different this time.
Oh,
I'm
okay.
not in the I'm not in a location where we have our stream going on right now. So even
Perfect.
if I close it, you will see me here.
I will say in the previous ones you did manage to do it at the right time though. If you had to have closed out of your stream, it was right at the end of the presentation. So
Okay. Well, sorry, like we couldn't take questions last time, but yeah, definitely we can talk more about it. And let me touch base a little bit on the loading part. So, for our users, that our loading concept is still the same UI what we had for the self-boarding tower. You have a mount level summary tab. You have a level details tab. There you have the options to, change the horizontal, lateral offset, vertical offsets. Again, we have different ways to model the define the antennas on the structure. We call it this as a quick editor. Then we have another one called level details tab. Quick editor has more like an Excel functionality where they can copy paste
hmm
different cells, drag and drop and all that stuff. It's just for easy for the users to enter the data
for mass
because
operations, it's definitely
also,
preferable.
especially for guide towers, think about that. If a 1500-foot guide tower, it has a lot of stuff. Sometimes the lightning itself, like FDA lightnings are like so many that you have to follow it, that you keep entering the data, it takes time. So why not just have a tool which can easily very flexible for them to do it.
Perfect. Yeah, I don't want it to take too much time, but I was just wanted to let everyone know that you don't have to draw these completely from scratch. You still have the tower generation wizard that pops up whenever you want to create a new tower, and
Yeah,
you can quickly input some basic parameters, and it'll give you a solid starting point for your tower to the point where
sure.
you're at to the point where you're just changing the member sizes after that.
And that is also very quick, like with our new tool. So let's say if you want to, just giving you a rundown very quickly. I think if we have few minutes, do we have some time?
Uh, let's see. Yeah, go for it.
Okay, so let's say you want to do a guide tower, right? So look at this. The tab for lattice is already there, and then we have a guide tower. We'll just say yes, it's a guide tower. We go to the
Perfect.
base structure detail, so you can set up the basic structure, the basic skeleton very quickly. So you want to pick three-sided, four-sided, and then you pick it. So think about this way: if I'll say my guide table base length is 0, it automatically takes the bottom width as 4. Like the same as the top width. Type of. But let's say if you put it, then it will allow you to do it. Okay, and different bracing types. You can do that. And I want to show you one feature which we did it again. With a collaboration with our tower partners. Uh, so I'll show you that one. So number of guy levels. Think about this as 5. I can easily change it whatever I want to. So it will automatically create those levels for you. Let's say we want to have 2 guy anchors. Okay. So you can fix the support and pin the support for the support blocks, the guy anchor support blocks, everything. And you can also, like define your I beams as well. Let's say if I will do differently. Uh, Let me show you very quickly here. Let's say if I'll put 0, and look at this, I have an I beam at the base. I can put the I beam also,
Oh, sweet.
and I'll show you what it is. It's a very cool feature we did it, like, and I think it's the ask from the industry that most of our towers has it.
Hmm.
So we create that one too, like for the users perspective, that they should be able to model their tower as is in the field.
Right.
So at this time, what is happening is that we are putting together the geometry of each panel, filling up the data in the guy panel. Yeah, everybody will thinking, oh, it's a little bit slow, but yeah, this is 3D model. It needs to prepare the data structure internally. So that's why sometimes guide tower takes a little bit of time,
Hmm.
and we hopefully there will be a technology where we can just update it very quickly soon in the. So here you can see that there is the I beam right there. We created it. Now
Nice.
look. So I have the basic structure. What I will
Right.
do is, if I want to go to guy details tab, I'll do my job on the guy anchor foundation, guy anchors, and guy details. I redefine my guy levels, whatever we want to. And just for everybody, that we have a capability of creating UPT sections. And when we say UPT sections, we have a guy cable also, that you can create your own UPT guy cables. Let's say you are modifying it, or maybe the cable is particularly only for that tower, and you don't want to put it in the database, so that you have a fear of losing the data base sometimes. So you can keep it as a UPT. UPT means it's a user provided table, which means that it will always be with that file forever.
Hmm.
So you can do that, all that stuff also. And once you define a, let's say we go to this guy, and once you click on a guy cable, so it will give you two options, whether you want to use the standard catalog or the UPT catalog. And there we have the list of cables. And recently we published another, a case study on a guy tower with one of our customers, and I'm very very pleased that the customer was willing to share
Yeah.
that information with us.
I'm
So
glad you brought that up. There's a little QR code in the top right of the screen for those of you watching. You just open up your camera app and just hover it over that, and it'll take you to our landing page. It's got our case studies on there, our previous webinars, and you can also request a trial there too. So we give you access to the full version of the program. We don't take any functionalities or anything like that. So if you feel like it's a good time for you to try it out and evaluate it, I can guarantee you it's going to be definitely more efficient once I give you some basic training. So definitely recommend trying out OpenTower Designer and checking it out for yourself.
I think that's what Bentley does a pretty good job. That we are not taking out any feature from our evaluation license either, right? So
Definitely. That
so they
annoys
can
me
save the
whenever I have to
file.
get software like that.
Oh yeah, I mean, like you spend a day to just figure it out the product, and then you cannot save the file. What's the deal, right? So I
Yeah,
need to know that what it does. How I need to see the report, or maybe let's say if I'm interested in a product, like I want to buy it, I have to recreate the whole file. So that's what the beauty of evaluation license of
yeah.
Bentley is, that we provide the full functionality of our product in that evaluation license.
Especially in the tower industry, I totally understand that it's fast paced, and if you're going to switch over, you need to understand if it's going to be able to do everything you need it to do, and just figure that out as soon as possible so you can make the switch over.
Yeah,
And so, and
definitely.
if you do decide to go that way too, included in the price of the license is 6 hours of personalized training, so we can train you. We also have professionally put together tutorial videos with actual tests at the end of each one of them to make sure you're up to par with uh, each sort of capability within the program, and then you should be up and running. And we find that people are up and running easily within a day, um, putting together towers and ultimately getting the report, which is the final deliverable to these tower owners. So yeah, feel free to submit a request for a license, and Pankaj and I will be here to help out with you. I,
Sure.
I think we're close to time here, unless anyone else has some last minute questions. I apologize if you did type a question and I'm not seeing it. This happened to me last time where it was kind of a delayed submission, but I don't see any right now. And if you do submit any afterward, I'll go ahead and answer those offline. Pankaj, if you
Sure.
don't have
I'll
anything else, I think we can call this one a day.
Sure, I think Guy Tower was the easiest one, right? The most
Yeah,
difficult tower, but is it
they're all
because we
easy.
already
Yeah,
covered we covered like most of them, right? The discrete, the linear. So I think Guy
yeah,
Tower,
that's
my
true.
you asked pretty good questions about the Tarcom, which is to me is the key to the Guy towers, as well as the behavior of the Guy cables on the tower. So
For
again,
sure.
if anybody wants to understand what our analysis is, we have provided a full detailed chapter in our manual. And if you want to access our manual, I think they can access it from the scan me, right? It will reach out to our open tower
Not the
page.
manual, but I mean, once I set you up with a evaluation license, it'll come install on your machine, and you
Okay,
can go through it as you need to understand the inner workings of the program. But yeah, all right. Thanks, Pankaj. I appreciate it, and thanks everyone for joining us. Um, and tune in for the next one.
sure. Thank you, everyone. Have a
Thanks,
good one.
Pankaj. Take care. Thanks,
Thanks,
everyone.
Francisco. Take
Bye.
care. Bye.